So you can connect your 5 volts to your breadboard, then connect to your ground to your breadboard, as denoted by the positive and negative. I just like making mine pretty, so I'm probably going to also change the colors on here. Just also so I don't get confused. So now you have a breadboard that is connected to your Arduino and now is powered. So let's say what we want to do is, what do we want to do? Just something, someone you can offer an idea if you want. Um, what's something basic that someone would want to do?
Maybe light and turn off some LEDs over internet commands.
Okay, maybe a little bit more basic than something with internet commands. We're looking for something quick here.
Okay, maybe just turn on and off an LED.
Yeah, okay, we can start with that. That's much more simple. Um, so let's just focus on actually just the hardware first. So first things first, just find an LED from in here. Uh, just do a normal LED. Um, so I don't know how many of you have taken intro to electrical engineering, but normally when you have an LED, you don't want to just connect it directly to power, so you usually have a resistor attached to it. Um, so you're gonna want to attach the resistor to the negative of the cathode, which is the shorter one, the one that isn't like this curved one. Um, that's how they denote whether or not which pin is positive and negative. Whichever pin is longer is going to be where the positive goes into. What the shorter one is the negative. So connect the resistor to the negative. Just put the resistance as just put it as 200 ohms.
Where does it go in the negative?
Sorry, what was that?
Where does the resistor go on the negative side?
It could go on the positive too. Actually, so the reason it has to go on the negative is because what we'll actually end up doing is because we need to attach this. You need to attach the positive to one of these digital pins up here because um
Is it because the diode can only let current go through like one side?
yes, so current only go so the reason why I'm putting it on the negative is because on the positive we need to put in the so what I was thinking is that we would use a button to control the LED. So we need to have some input voltage, and technically speaking, we don't. It doesn't matter what side the resistor goes on, as long as you have the resistor in between where the voltage is coming in and the positive of the LED. The reason why I'm doing this is because I'm going to be putting a button somewhere. If I can pull up a button, um, I'm gonna be basically what I'm gonna be trying to doing. What I'm gonna be trying to do is whenever we press this button, the LED will turn on. So what I need to do is I need to create a digital output from this top row up here, which will then come through this wire and go into the positive. So that's why I have the resistor on the negative, just so that I don't have this current passing. I don't have the. I would need to hang on. How do I put this? I could. I actually don't know how to rotate this. Okay, there we go. So I could, technically speaking, have this resistor like this and have it going into the positive. Oh, whoops. Sorry, having some difficulties. So I could have it going into the positive like this, and then just have the negative going across. Just in the software, it's a little bit more simple to just to just do it and have the resistor going in on the negative. I think doing it this way, everything should work out as intended. So I'm just gonna put my stuff. Oh wait, I put that in the wrong place, but I'll fix it. Um, okay, this is annoying. There we go. So for now, I'm just gonna connect the my wire to the that's it, up here to the positive, and then I'm gonna put the resistor to the ground. And then I already put in this push button up here. On one side, you need to attach from the positive to one side of the button, and then you need a resistor. I'll just copy and paste this one of some high voltage going from the other side of the button to the ground. The reason why this needs to be high is just because we're actually going to put a wire in between the button and that resistor, and we will send it over to one of our digital pins over here. I'll just put it to 13. And so basically and I'll just put it at 1,000 ohms. So basically when we push down this button, the current will be able to pass through the button, and instead of going to the directly to the ground, there will also be some going to the to 13, which will be able to be picked up as a signal, which will then be able to turn on our LED. So now that we're here, I think we can actually start coding. I'll zoom out in case if somebody still needs to look at the circuit over here. So first things first, we'll need to initialize variables. So um, so if you type in constant initialize, and then I'm gonna create some variables that are LED pin equals my LED is connected to 2, so I just put LED pin equals 2, and then I can do the same thing for my button, and then I'll say button pin equals 13. Now neither of these happen to be analog pins, just because of our purposes. We don't need analog pins because analog pins are a little bit more of a pain. So what I can do now is I can now under this void setup area, I can now initialize our pins as outputs and inputs. So pin 13 just so happens we are using that, but I'm going to put in button pin, which is our pin that we're using for a button, obviously. And so our button pin, since we are going to be intaking current into this pin, this is actually going to be an input. And then we do the same exact thing for our LED pin, except it is going to be an output. And then I can delete this. And so now that we're in our void loop, the void loop is actually where we actually write the majority of our code. So the first thing that we're going to need to do is we're going to need to read whether or not the button is being pressed. So what we can do is we can say digital read button pin. Hang on. Okay, we actually should probably hang on. I'm gonna add just to make things more simple, because I could just put this into what we're actually needing to do, but I'm just gonna create another variable that's just switch state. So then we can do switch state equals digital read button pin, and then we can write an if statement and we can say if switch state equals high, which is basically just saying if the button is pressed, then we will uh, digital write LED pin high. Also, be sure that you're capitalizing things where I'm capitalizing because the code is case sensitive, I'm pretty sure. So like obviously with like things like switch state, like names, you obviously need to be case sensitive. But just to be safe, just make sure that you're keeping your capitalization consistent. And then once when you do this, you can put a close bracket. Um, make sure that you put an open and close bracket, or else it won't work properly. Then if we want to have the LED turned on only when we're pressing the button, we write an else statement that basically says digital write. I can spell digital write LED pin low. So ideally, if I didn't screw anything up, oh, hang on, let me. And then you should also probably add a delay of some sort, just to be safe. So I'm gonna put a delay of I'll say half a second. So this is our void loop. This is where most of our code actually is gonna be. Up here we have all of the initialization of all of our oh wait, hang on, I don't know how to initialize states. That should be switch state equals 0. Make sure that you have semicolons at the end of all of your statements, at the end of all your lines. Um, I know if the only coding class you've ever taken is MATLAB, MATLAB doesn't require anything at the end, but it's very important for Arduino that you do have semicolons at the ends of all your lines. So now if you have, hopefully if I've done my coding right, which it seems that I have, whenever you press the button, whenever you click on this button, that LED lights up. Is anyone who's following along having any issue getting to that point?
I have one question.
Yes.
While entering the initials like LED pin 2, button pin 13, does it reflect on the numbers written here?
Uh, sorry, what was that?
I mean, you have entered the initials like LED pin 2,
Yes.
button pin. What does it actually mean?
Oh, like the numbers?
Yeah.
What do the numbers mean? Oh,
Yeah.
they correspond to these pins over here. So like I have my button connected to pin 13 up
Mm,
here, and then
yeah.
I have my LED connected to pin
Okay.
2. So um, this is just initializing that I have what I'm going to be calling my button pin is
Mhm.
connected to pin 13, and then this is indicating that I have my LED connected to pin 2. So it's just attaching a variable to pins. Like if I really wanted to, I could delete these first two lines.
Mhm.
Hang on, I need to stop my simulation. I could delete these first two lines and then just put in the pin numbers separately. And let me see, 13, and then just replace everywhere where LED pin and button pin were with their proper numbers, and then it will still function the same exact way. It's just so that when you actually look back at your code, um, it'll make it a little bit more it will make it a little bit more identifiable. so that you're not just looking at random numbers. It just lets it at a glance, it lets you know what everything is connected to and what sensors or components are attached to which specific pins.
Okay.
Any other questions or concerns? Oh, whoops. Okay. Hmm. Let's see. Let's maybe work with an analog sensor. So let me just. Okay, I guess I can't. Guess there's no way to quickly clear this, so I guess I'm just gonna have to do this, or maybe. No, that's gonna take too long. I'll just delete everything individually, which also isn't ideal. So let's see, what can we do now? Let's see, yeah, let's work with some other sensors that are a bit more practical. We can work with the temperature sensor actually, because there's another important. It'd be as most likely a fair amount of people will most likely be using a temperature sensor of some kind, so we might as well go over it. So I don't know why I disconnected these. That was dumb of me. So we have our temperature sensor here, and you'll notice it has 3 pins. This pin, if you hover over them, it'll tell you what they are. But so this one's power, this one's the voltage out, which is what you would use for what you would use to gather data, and then you have your ground. So I'm gonna go ahead and attach my positive and ground to the proper pins, and then I'm going to attach one of my my middle pin to A0. The reason I have to do it to this specific pin, I mean, I could do it to any of the pins in this row. Oh, do we have a message? Doesn't need a resistor. I don't. If I remember correctly, I don't think it does. Let me check that real quick. You know what? This one that I'm looking at does say it does that. Don't tell my EEL professor that I never did that. So what I'll do is I'll just delete this on the positive. Uh, I'll delete that on the positive, and then I will add a resistor. The other thing is that this week, and I was literally going over this, and like I was just going over like what I could possibly do, and I literally did something with a temperature sensor, and I didn't put a resistor on it, so it worked. So, you know, here let me color things differently so things don't get as confusing, because everything's green for some reason. So I'll put that to black. That can stay green. So all that you need to record temperature is this setup. That's basically all you need. Obviously, though, we need to change the code. So we probably should get to doing that. So what we need to do to start off with is we need to initialize our pin. So what we can do is we can say initialize temp pin, and then wait, why am I doing that? And then you can define it to whatever pin you attach to. In this case, I have A0. Then in your void setup, sorry, I'm getting lost here. Not in this. I'm I got lost on my monitor. Um, hang on. Okay, so we can delete this. We're gonna want to do something that's called the serial monitor. We're gonna use what's called the serial monitor. As you can see it down here, this actually does exist in the actual Arduino IDE as well, and it's useful for seeing what data is being output. So we're gonna start the serial monitor, and we're gonna type serial dot begin, and then we're gonna put 9600. There are more values that you could put in here. I forget what exactly they are. I always use 9600 because it seems like that's the most common. But basically, what it does is that just defines the bit rate. It defines how quickly it will be gathering the data. So we do that, and then we can go into our void loop, delete all of this, and then we can initialize. I'm just going to call this temp, or actually I'll just call this X for now, just because I don't feel like writing anything, coming up with names of variables. So X is going to be, do we need to put temp in as an input? No, we don't need to do that because this row is only inputs. Um, Up here, so the reason we need to do it up here is because these pins can be outputs or inputs. Because for digital, it's either, signal in, signal out, it doesn't really matter. But for analog, since you can have a range of values, you can't necessarily just have them be in or out. So all of these pins down here are exclusively in, and then all these pulse width modulation pins over here, the ones with the little squiggles next to them that I mentioned last time, those are exclusively output for analog. So if you want output analog, you need these squiggly ones over here. If you want input analog, you need to use these pins down here. And then there's a specific way to analyze or to indicate that you want to use pulse width modulation and with one of these pins. We can possibly go over that in a bit. But so just to continue on with this, we can analog read and temp pin. And so that will basically read our data off of temp pin. But the thing is that that's going to be in the form of not temperature. It's going to be as just an electrical signal. So then we can use this to get a voltage. So we can take X and multiply it times 5. And that will give us a voltage as to what's coming out of the temperature sensor. And then volt is slash equal. So the reason we do that is because 1024 is the max voltage you can have, or the max signal, because I think Arduino's only the bits that they read is between 1 or 0 and 1024, if I'm remembering correctly. So this is just to make sure that 1023, thank you. Um, um, so this is just to make sure that it's not it's not at that value. And then down here we have serial print voltage. We don't really need to do that. So now what we can basically do is we can create a calculation for temperature from this voltage. And it's basically float. Let's just create a variable temp equals, and then you just do the voltage, which in my case is volt minus 0.5, and then multiply that entire thing by 100. And so this will convert the voltage that we're reading from this pin, and we'll convert it into a readable temperature. And then going back to the serial monitor, what we can do is we can type in serial print and then ln, and then the variable we want it to display, which in this case is temp. And then I'm going to put a delay on it just so that it doesn't, just constantly read, because then it doesn't look good. I'm going to put on just keep in mind all the delays are in milliseconds, so this is going to be a 1/10 of a second delay. And now hopefully when I actually run it, it will run properly. We all make mistakes. That's fine. Let's see what I did wrong. So it seems that I am a dunce. Okay, stop simulation. That it's helpful to, oh shoot. Everything's going to chaos now. Okay. I'll change that to 200. Okay. So now, it's helpful to have your positive connected to your positive. So now hopefully if we open our ceiling monitor, I have no way of changing the temperature of this, but it should be reading around room temperature, which is around 24 degrees or 25 degrees Celsius, which is what this is reading. As far as I am concerned, I do not believe there's a method of increasing the temperature in the simulation. So, oh wait, but there is a way that we can check that we are correct, because they did give I found this earlier. In here they do have a temperature measuring circuit. And so what we can do is so if we run our simulation, it will give us an output voltage from the temperature sensor of 749 millivolts. And then if you plug that into a calculator and you use the equation that we used in our code, we get around 25, roughly the same. If I actually do the error, there's technically let's see, divided by 24.71. There's a 0.7% error there, which is, close enough. Not all this is going to be perfect, but either way, this will give you a good idea of recording. And there are also other external there are other programs that you can find online. I've used one called CoolTerm before, which can essentially, when you're actually using your Arduino, you have this plug over here. This would be going off into your computer, and you can use it as a form of power. Obviously, this can't work if you're using another form of power using this plug over here. But if you have this plug plugged in while your code is running and while you're gathering temperature data, you can use this software called CoolTerm. And essentially what it does is, rather than the data coming off of this temperature sensor going to your serial monitor down here, it gets ripped off and goes to CoolTerm instead, and we'll plot it. It will plot time versus like the temperature you're recording, and we'll put it into a CSV, which can be opened using Excel. So just useful things like that. It seems like we're probably only going to have time for one more, if any. Does anyone have any questions on this before we move on? Okay. Here, let me start to clear some of this a little bit. Just because it kind of came up and while we were going over that last one, I kind of want to go over how to use one of the PWM uh, sorry, one of the PWM pins up here. So just thinking of like a general one, what I was thinking, and let me, no, that's fine actually. So first things first, I'm just gonna create a new circuit real quick. So basically what I'm planning on doing is I'm just going to create a, and let me see. I'm referencing something right now because I wasn't prepared to talk about PWM and I haven't done enough in my spare time because I am a materials engineer and by no means am I an authority on electrical engineering. Let me see. Oh, hang on. I think I might have found it. Okay. Yeah. I think we might actually be able to do something else. Let's try. I don't know. I've never used the RGB LEDs in this, but we can try using RGB LEDs. So RGB LEDs function under the same principles as normal LEDs, except they have 4 pins instead of the traditional 2. One's going to be for your red, the other is going to be a negative, and then you're going to have blue and green. And based off of what proportions of red, green, and blue you produce, you can produce different colors. So probably first thing you'll need to do is get some resistors. I just say probably, let me see, probably around like 300 would be good. And then I just copy and paste those to the other cathodes that you need, or the other anodes that you need positive. And then from here to here, you can put it on negative. And so now if I start the simulation, it should produce white, yeah. Here, let's do this though. Let's make things a little bit more interesting. What we can do is we can actually use pulse width modulation. I'm going to move this over here and then I'm going to put, whoops. I'm going to put these up here and then I'll create another path down here. So what I'm going to do is I'm going to use these pins up here and I'm going to, so all the ones that can use pulse width modulation are the ones with the little squiggly. So just as long as you find ones with little squigglies, there should be 6 of them. You can use it. So I'm just gonna take a second to connect all of these, and then I'm probably gonna color coordinate them too because I am extra. So once when you have all your wires connected, we can start coding. If I can remember what colors go where. So code. What we're going to need to do is we're going to need to initialize several different pins. So we'll need to initialize, we'll call 9, or hand, so let's write green pin equals 9. Then we can have in red pin equals 11, and then in blue pin equals, oh wait, I misspelled red. That's embarrassing. 10. So now that we have this set up, what we can do is, let's see. I'm trying to think this through in my head, how to do this. I don't think we, oh wait, yeah, we need to set up all the pins. So we have pin mode, and then we say green pin output. And then I'm just going to copy and paste that and put it for red and blue as well. And also remember semicolons, because that's also important. Okay. And then what we can do is then we can go in here and then we can say, we're not going to do anything fancy here. We're just going to type in values. We're not going to use some like equation or anything to assign values to anything. So we're just going to put analog, right, I can spell, and then you put whatever pin. So in this case, I'll do red pin, and then to start out, I'll do 255, which is the max you can have for a color. And then I'm just going to copy and paste this and then do it for blue and green as well. So if I did my coding correct, so when I turn on the circuit, it lights up white because red, green, and blue, when all to their max, produces white. Now, if I wanted to do only red, I would select the green and blue and make their value 0. And then it will come out red. And if I did it with the other way around, basically every color of light that can be produced by one of these LEDs is just a proportion of some red, green, and blue light values that is on a range from 0 to 255. So if I looked up a light circle, so let me see if there are sometimes, yeah, here, this is what I'm looking for. This is in the ballpark of what I'm looking for. So basically, this is basically all of the red, green, and blue values that you need to create, or that you need to use to create different colors. And so basically, if you wanted to generate different colors, that's how you would do it, is you would just change out these different colors. So that, but it's also occurring to me that that graph is wrong because it says that cyan is created by only red, which isn't the case. But like if I wanted to create like a light green, I could do 128. I'm good at this, and then start simulation. That's not light green. Why did this thing lie to me? Okay, don't trust these diagrams. You know what? Everything's going to chaos. But yeah, so like all the main thing about these pins up here is that while they can only be inputs while or outputs while they're analog, you have to find some way to generate a value that will basically act as a proportion to basically tell how much voltage should be sent to it. So like when I put this at 255, it's telling the circuit to send the max voltage. Um, like over here, it's telling 0 voltage should be sent to the green pin. This is saying roughly half voltage should be sent to the blue pin. So there's just other things like that. Let me see if there's other good uh, examples. Let's take a trip down Google. Well, I guess this is another good example. Hang on. Oh, whoops. No, that's not right. That's also not right. I'm somehow getting worse at this. Um, so another example that we could use for this is a potentiometer. Let me see. So a potentiometer is just a variable resistor. I'll turn it to, you know what? I'll turn it to 1,000 kilo ohms. So a potentiometer is just a fancy variable resistor where here I'll do this. So what we can do is we can attach, this is terminal 1, wiper, terminal 2. Okay, I see. So this most likely is going to have a resistor on it. Set up everyone. So I believe if I do this, no, I'm being stupid. Okay. So basically, based off how much you turn this, I guess I can't turn it while it's not running. Basically, how much you turn that will change the. It's a variable resistor. So as you turn this dial, as you rotate this dial, it increases or decreases the resistance. I think as you rotate clockwise, it increases the resistance. So it will change the signal coming through this wire, and you can use it to change the brightness of things. Like I know I can go actually back out to here where I have all these other ones. Oh, I guess I got rid of it. That's fine. I'll just create a new one. The other nice thing about Tinkercad is they have built in like pre-made sample circuits that also have like the code made, which is helpful to look if you don't know necessarily how to do something. But so um, I don't want to break my computer. You don't need to be following along for this part, by the way. But so this is an example of a Arduino LCD display. And so if you just run this program, so this program, it's designed to just say hello world, and then for the amount of time that the program is active, it adds another number to it. So like right now it's just counting up from the 0 for every second. But if I rotate the variable resistor, it's a little bit sensitive. But um, ideally, if this was real life, it would be dimming, but you can kind of see it a little bit, like right there. It basically this this variable resistor, this potentiometer, it can change the brightness because this is going to the ground of the entire thing. So it is changing the current through it, and so it's just changing how bright the screen gets. So you could use it to change the brightness of this. You could use it to change the brightness of an LED. Obviously, the LED would need to be attached to one of these or attached directly to the potentiometer. Um, but it is useful. Pulse width modulation is a useful thing, despite being annoying when asked about on exams. But that's the general gist of this stuff. Most of the stuff that you can find or like that you'll ever need questions on, you can find online. Arduino has a bounty of resources on all of this. Like, if I just bring up another thing, like let's say I wanted to know, yeah, like or more PWM examples. Let's see. You want to know like, oh, like more about the serial monitor and how you can change display things. You can find lessons on other websites about how you can get different uses out of the serial monitor. Like there are ways that you can display your data in multiple columns using the serial monitor. Um, Everything about Arduino is essentially at a Google away. Like it between your peers, your group mates, and whatever resources you can find online, you will be able to figure any problems that you have out most likely. Um, I am mostly self-taught on Arduino, partly from what's it called? Elements of electrical engineering, but it is it's not that bad, to be honest. Like it could be much worse, but that's all that I really have to say about this, unless if anyone else has questions. Okay, so if that's it, then I will. Hey, let me see. No, that's not what I'm looking for. I'll send the chat in, or I'll send the sign-in link back in the chat, just in case if some people didn't have the ability to sign in at the beginning. Other than that, you guys are good to go. We're at our hour, so thank you guys for coming. If you haven't signed up for a group, please be sure to do that. I'll send the link after this. Um, uh, how are these meetings going to be like? So once when we actually start, we'll probably have less meetings, unless if obviously by the time that we get back um to school in the spring, I don't know what the status of COVID and what is going to be allowed to be done on campus is. Most likely, if um, we have a similar format in the spring and we're not allowed to meet in person, then the actual project, once when we hit the spring, is going to be more of maybe every couple of weeks we'll have a meeting where people can ask questions, or maybe we'll do it every week, depending on everybody's availability. But most of the work will most likely be done on your own, and we'll have weekly or bi-weekly sessions where you guys can come in and ask any questions if you're running into issues. It, does that make sense? Okay. Any other questions? Okay. Then just remember, I know I've said this plenty of times, if you haven't signed up yet, I will send the link to the Google sheet that will allow you to sign up. Um, once when I do that, feel free to sign up for whatever team you want. I currently have 8 on there. If we surpass that, I don't think we will, but if we happen to surpass that, I can add more teams. We're not locked on how many teams we can have. But once when you are there, once when you have signed up and you have a full team, be sure to email the other members of your team. Try to set up some form of communication because email is obviously not the most efficient. And then you guys can start discussing. You can start discussing your project, and then after break, after Thanksgiving break, when we have the next one of these meetings, what we can probably do is we can put you guys into breakout rooms if you are all in groups, and you guys, if you haven't already discussed it, you can take the time to discuss um, to discuss with each other what sensors you want and what things you're looking for out of this project, and then from there you guys can move forward and work on a budget and get that submitted. All good?
So you mean to say like each team is gonna have like a coffee maker that they're gonna work on?
Yes. Just
Oh wow.
yeah.
I thought this was like a group project, like
E-
Scrub is a group and then we have our internal groups.
yes, kind of in a way, but you guys are gonna be more working on it at your it. So it's more of just a project for you guys, sponsored by Scro. Think of it more that way.
Okay.
Um, so you guys can work at your own pace. Obviously, we need all of our parts back. We're not sure if we're gonna want those coffee makers back because they are gonna be $10 or something around that ballpark. Um, but the coffee makers are yours to do what you will with. Um, just don't electrocute yourself. Um, Other than that, like you guys, once when you guys submit your budget or your parts of your list part, or it's been a long week, and I know it's only Monday, but it's been a long week. Once when you guys have submitted your list of parts and we have it approved, we'll try to get like a general sense of like what people want, and then we'll send out a universal kit of parts to each group. Um, so basically, every group will be receiving the same exact parts, even if like a group knows that they aren't going to use those parts. We're just gonna order the parts in bulk and then give everybody excess. Um, just because things happen. Um, but we just want to make sure that we have everything ready around the beginning of next semester. So we'll probably have like 1 GBM after we come back from break, and then we'll probably the next week have another one of these sorts of meetings, and we'll get into contact with group leaders and or team captains, whatever you want to refer to them as, and we'll try to get everybody's kits to them so that you can actually start working on the physical circuit and stuff. But like I said earlier today, like you guys can feel free to use Tinkercad. It's a pretty good resource, and I didn't show it earlier in the lecture, but if I and let's see, oh, let me screen share real quick again. If I pull back up Tinkercad, what you can actually do is this one's not a great one. Let me go back to this one. This one's a bit more complicated. So let me stop this. What I can actually do is if I go to the code, I can download the code directly from here. So let's say if you design your prototype in Tinkercad, you can write all of your code, make sure it's working, make sure you don't have any bugs, and you can download it, and it will download the exact file that will be used in the Arduino IDE, and you can open the Arduino IDE directly from there, and it'll open your it'll open your file that you had from Tinkercad, and then similarly, you can also look at your parts list that you've used in your practice circuit. So like here, you have your Uno, your LCD, your potentiometer, and your resistors, and you can actually download it as an Excel sheet. And so if you've gotten your idea pretty nailed down, you can just like export it directly from Tinkercad. You don't need to create an extra. You don't need to create an extra. What's it called? Excel spreadsheet. You can just. No, I don't need that. You can just export it directly to Excel, and then this can be what you submit to us as your quote unquote budget. But obviously, that requires a bit more planning than probably you guys are capable of. So like if you just have like a general idea of uh what you want to do, like just having an idea of what you want to do, knowing what sensors you want, even though you might not necessarily know how they're all going to connect together, that's fine, because I realize we're even though we have Thanksgiving break, most likely people don't want to be doing work on Thanksgiving break. And then after that, you only have a couple weeks, and then final exams are coming up. So as long as you have something to show us by the time that exam weeks rolls around, it'll be good enough for us to give you those sensors and everything that you need. Any other questions? Okay, if no one has any other questions, you guys are good to go.
Cool. Yeah, thanks, Hunter.
No problem. Thanks for coming.
You guys have a good day.
Thanks, you too.